Yo, welcome everyone. What you're about to watch is an insert from my most advanced Pyro workshop that I ever made, creating custom microsolvers in Houdini. Essentially, I created Maximus Detailus, which kind of replaced all the turbulences and disturbances that I use. It's kind of like a complete package tool for that. It really gives you the maximum amount of details that you can in a Pyro sim. Then I've built the Soot or die. Essentially, Soot is the black stuff that happens when you have incomplete combustion. So when you don't have enough oxygen and low heat is when the soot will get spawned. So that's also a tool that I've made. And then on the side, I was creating baby erode. So baby erode, nothing fancy, but it really helps when it comes to eroding density. So eroding hot density or cold density. So if the density is hot, that's where you have a lot of fire, right? And we all know that when you're rendering fire and if you have dense smoke, the fire is not going to be visible. So the fire is going to look like ass. So essentially what you have to do is you have to reduce the opacity of the dense areas in the smoke so you can actually then see the fire coming through. So baby erode essentially does that in the sim, so you can create nice pockets of space for your fire. So it's gonna just blend really nicely together. You can watch all of that. You can learn how to do it in the creating custom microsolvers in Houdini workshop. I really think we need to rename that workshop because it's I don't know what yet, but I think we should rename it. But this, what you're gonna watch, is an insert from one of the parts from the workshop where I just demo some of the tools. All right, enjoy.
All right, all of you pyromaniacs, welcome. So let's take a look at Soot or die. So like I said before, let me turn everything off. Turn this off. The main thing that we need is our oxygen. Let me put this to 0. So oxygen is just created here on the volume source and just using density. And then this is just to visualize that oxygen field. This is not actually creating the oxygen field. It's just a visualizer. Now, soot or incomplete combustion is created when there is not enough oxygen and the flame or the temperature is quite low. That's where we get dirty burn or soot. The way we get that is essentially, if we look at it as multi-field, our temperature, or in this case, I'm visualizing flame where we have a lot of heat. That's where the flame / temperature is going to start consuming oxygen, and based on a bunch of if statements and how hot temperature is and how much oxygen we have, then based on that you get that dirty burn, which can happen in flamethrowers. Well, it happens on flamethrowers, gasoline explosions, and candle flame, like all over the place, right? So in this case, right now we are not eroding any oxygen. If we're not eroding any oxygen, which is this is one of the major kind of parameters. If we're not eroding, we're not going to be emitting any soot. There is a way to bypass that in a way where it's like, okay, but wherever we have flame, just erode soot there as well. And this will create, let me just turn on back our visualizer. This will now just create a very simple flame equals soot kind of parameter. So we're going to start getting that black smoke. And honestly, in some cases, that might be enough. And almost like for flamethrowers where you just need a lot of black smoke, you could add just a bit of this as well. So if I turn off our oxygen, you can see we are now emitting black smoke. And just as a tangent, for all of this to work, we do need to create a gas match field. So we are creating a soot field based on density. We're also creating a delta based on flame. And this was our erosion mask for the baby erode. So, okay, let's remove this one. I might put this in a separate parameter. Not sure yet. Because the main thing is actually when flame starts eroding. When flame starts eroding, our oxygen, that creates the incomplete combustion. And you can see here, we're getting the most smoke generation here. There is some here as well, which would happen, but the majority is happening here. So if I remove the soot layer, you'll be able to see our flame heat, essentially heat, is going to start evaporating our oxygen. A way to visualize that is through our delta. So this is our delta, and whenever you see the red bits is where the incomplete combustion is occurring. And this is just a debug visualizer that I created for myself, but it also gives you a good way to just visually see where the emission of soot is being generated. You can always just not erode a lot. So we're still going to be getting the black soot, but it's going to be less prominent now, and our oxygen is also going to live for longer. So it just means that our flame is still eroding into our oxygen, but we're going to be getting less black smoke emission. So you can see we're still eroding, and we are still going to be emitting from here, but now we're going to be emitting black smoke longer because our oxygen is still present, but it's kind of slowly being eroded by the flame. So in a way, you have to, with all of these parameters, we're just creating a, oops, what have I done? Come on, go back. We're just creating a kind of like a dance between a lot of these conditions, right? A lot of these if statements, and we're just saying, okay, so if this happens, and if there's a bit more erosion, if there's a bit less erosion, we can be eroding this 100%. So now it's just going to be extremely aggressive immediately, right? And this is something that would happen with like a flamethrower. So you would be eroding a lot immediately and just be generating a lot of that black smoke. I'm going to turn back our multi-field here so we can see what's happening. I'll remove our oxygen, not remove, just the visualizer, and we don't need to see the delta anymore. All right. Soot intensity is quite self-explanatory, right? So this is a global multiplier for all of it. So now we're just going to get less of that black smoke. And if you're ever in doubt, just click me. So fire needs oxygen to burn cleanly. When there's plenty of oxygen, that equals complete combustion, CO2 plus water, no soot. No soot when oxygen is starved, not enough, equals incomplete combustion, equals carbon particles, which is soot. So this is just our soot intensity. This is when oxygen gets burned by flame, how much of that soot do we want? So that is coming from here. This is the global multiplier. This is the main kind of intensity for when oxygen gets burned. But if you're also using flame to soot, then the global multiplier will multiply all of them, right? So now we have one here, but we can obviously say, 150, and we're going to get a lot of black smoke again. So just global multiplier at the top. Then we have the flame to soot that I already showed you. This is the soot maximum value. Essentially, if you're generating a lot of soot, so, just bananas. We just go bananas here. We're now emitting soot from, immediately, and all the consumed oxygen goes directly into soot. We're just generating a lot of smoke. But you can clamp how much of that do we want. So this is a hard cap on soot, as you saw that there before it disappeared. I think a good rule of thumb is like 10, but obviously these are bananas. So I think it was 30. cold flame threshold. So right now we are emitting from the threshold for cold flame is quite high. So only spawn Soot when flame is cold. 0.1 will spawn 0.1 will spawn anything below that threshold. Right now it's quite high, so we are emitting Soot even when the flame is quite hot. You can go back to our trusty visualizers again. So we're going to be emitting a lot of Soot here, even though this flame here is still quite hot, which is, it's fine. It's fine. Don't worry about it. This is still like an artistic process. So, but if you're like, no, but it needs to be quite cold, then it's just going to happen later. So now we're going to be getting way more surgical pockets where we are actually spawning Soot. And in this case, we do need to go higher with to visualize the delta, and we can maybe go even lower. So only when flame temperature is like really low, that's when you start spawning it. And because of this, we're also going to be spawning less Soot now. But this will give you more surgical kind of precision. So if we would be if we would be eroding less of the oxygen, and our cold flame threshold is quite low, we're going to get less Soot, and also it's going to be, actually, let's erode this even less. So now we're getting really, really small pockets of where we are actually spawning our Soot. So that's how you can be a bit more surgical. But honestly, if you go for this flamethrower example, 10 was fine. And then, it's up to you how much you want to erode into the oxygen. The oxygen threshold is very similar to the cold flame threshold. So only emit when oxygen is almost fully depleted. If you go to 10, now we're just going to be spawning Soot all over the place. 0.1 is going to ensure that we're only spawning where we are very low in those values. We can clamp our oxygen. So in the beginning, I didn't have this. If we don't clamp it, sometimes the oxygen values, it's going to depend on your simulation. But if your density values are too high, if you remember, we are spawning oxygen based on density. So if your density from your emitter is extremely high, that means that your oxygen is going to be extremely high as well. This just ensures that we don't go above a certain threshold of oxygen. This also means if you have less oxygen, now the erosion is going to be happening faster, right? So less oxygen means that when there's just a tiny bit of flame or temperature, because we don't have a lot of oxygen to begin with, because we're clamping it to 1, it's eroding it faster, and we're going to start getting faster Soot. So just keep that in mind. So in this case, you would have to go lower with how much we are eroding it based on temperature. So let's put this back to like 10. I think it was 100, but I think 10 would be a healthy number to have. Good. Let's put back our Soot so we can visualize it. Should we just put our flame as well? Maybe later. The next parameters are all about the erosion / removal of soot. So if we go really low, 1 is no fade. I think I'll invert this. Honestly, it's more intuitive if higher number is more fade than vice versa. But right now, we're going to be eroding a lot of soot very fast. So let me also remove the delta. So we are going to be generating soot. And this is also, again, if you want to generate just those really quick pockets of soot like you see here. So we generate soot and it's going to be injected into the sim, and then it's going to be quickly eroded away. This is going to give you very nice black pockets and just more natural and realistic kind of look to your, especially to your gasoline explosions, right? This is a bit too much now. So what I like to do actually is I go quite low on this, so almost no erosion, but I do erode with the temperature. So this is the temperature threshold, right? So below this, no temperature erosion. So if the temperature is cold, we're not eroding, but if it's hot, we are eroding. And then this is how much we are eroding. So a value of 7 is actually going to be eroding our soot quite fast. So we are spawning it. And then where temperature is quite hot, that's when we're going to start eroding by 0.7. And this will again give us, you can see just these pockets, these caps where there is, before it gets eroded. And this, I saw this was giving me very nice results as well. So if we put away our oxygen, are we depleting our density so fast? So in this case, I was depleting my density really fast, but because we are generating soot, you can see these black pockets appearing, and then they're going to disappear because temperature is eroding it. And when we disappear it, we are going to go back to just having flame appearing, right? So this is pure flame, and we have some black pockets here. And I think this might be, it's actually pretty cool. I think I'm eroding a bit too fast, so I'll go to 5. I'll do a flipbook of this. So this is going to give us very cool pockets where flame has a chance to shine, but then we're going to get pockets of black smoke and soot being formed. So here in these areas, we're going to get a lot of the, in these areas, a lot of the scatter is going to be visible, but then in these areas, we're going to get actual flame, right, and fire. And this is what I think was missing from a lot of the flamethrowers so far in CG. And I think a combination of this is the solution. So yeah, that works. We can also use flame to erode soot. In this case, I'm not using that, but it's going to work the same as temperature. And then we have oxygen removing soot and oxygen clean soot. So the oxygen removing soot is also very similar to the temperature. If we do have oxygen still left in the simulation, or if oxygen for some reason comes back into the sim, based on this threshold, this is how much oxygen starts removing soot. You can use these two as well. I barely use this. I mostly just use erosion by temperature or just natural soot fade. But you can always also just use it like I was here, like I was using it here, which is using the baby erode and also remove soot based on that. So this also works pretty well. And then the only other feature that I added yesterday morning was the soot adds to temp. So if we don't erode a lot of it and we don't add soot to temp, we're going to get a lot of soot that's being generated, but it's going to feel like it after it's being generated because we are removing flame and temperature. And black smoke in theory is and should be still very, very hot. this whole setup would be really good for volcanoes as well. So I just felt like, so this is still very hot, but because our temperature is, getting removed, it was just looking a bit too slow. So it was kind of stopping. The buoyancy was not as effective. But as soon as I put this on, let me actually do a flip book. Now we're going to be adding Soot back to temperature, which means that the buoyancy is going to be working again. So it is working now, but I think because the amount of soot we are emitting, it's becoming it's actually moving up too much. And that's why I added the soot temp max, but also let's just add less and maybe clamp it at 50. It still feels like it's raising too much, so I'll do 20. I'll add 2 and reduce it to 20. But yeah, that's why I added the soot max control, because we still wanted to be pushing our buoyancy up, but we don't want it to go off the rails and be too intense. Yeah, this kind of works. So it isn't stopping, but it's still kind of gradually going up because the smoke is still pretty hot. Yep, so that's pretty much it. These are all the parameters and how you can change this. So like I said before, this is very useful for flamethrowers, for explosions. You can just add like these kind of details to your explosions that otherwise would be very difficult to do. And in some cases you can be more subtle, you can go more crazy. It's completely up to you and based on the needs of the explosion, but you can obviously also do small fires, you can do candle flame, anything that, this is like a really bad candle flame, but anything that would emit soot or have incomplete combustion, you can add this to, and it's gonna just add to the realism. And yeah, I just wanted to make a tool that I would use and it would be easy to use. So hopefully this is going to be useful to you. And also, yeah, always remember to use Maximus the Tylus to get all the nice, look at that. And like, this is very low res and you can already see the nice breakups it's doing. Whew. All right, I need to have some lunch, but thank you guys for watching. Hopefully you learned something new. I really hope the tools are going to be useful. Let's continue with the other examples. So we have I'm going to show you how this would work on I want to show you how to use Maximus on tornadoes like these. Have another tornado. And then the wide kind of bigger flamethrower that can be used for rocket launches, and also this would be perfect for volcano evaporations as well. So this is pretty cool. So yeah, let's take a look at that in the next few videos.